Hello, in this video we are going to go over the solution of the problem 62, unique paths. And in this problem there is a robot on an n by n grid. The robot is initially located at the top left corner, and the robot tries to move to the bottom right corner. And the robot can only move either down or right at any point in time. Given the two integers m and n that are size of our grid, we are supposed to return the number of possible unique paths that the robot can take to reach the bottom right corner. Let's consider this example where number of rows n is 3 and number of columns are 7. So we are going to start from the top left corner. We are going to start here and we are going to finish here. And we can only move to down or right. For example, if we are located at this cell, so we can go here or we can go here. Now let's assume that instead of starting at the top left corner, we start at this cell. So starting at this cell, and when we are going to finish at the bottom right corner, so how many unique paths I have? That is 1, because I can only move to the right. How about this cell? That is again 1, because I have to move to the right. The other cell? 1. There is only one way for this cell. So for all of the cells in the last row, we have the only one possible move. Okay. Now let's consider the last column. For example, this cell. How many unique paths I have? Only 1, because I have to move down. How about this one? That is again 1, because I have to move down. Okay. Now let's consider this cell. When I'm at this cell, I can go to right, and if I go to right, I have only one possible path, one unique path. And if I go to down, I have another one. So I can sum them. I have 2 possible unique paths. One of them, for example, is this one. The other one is this one. Okay, so we get 2 here. Okay, let's see if we can come up with a formula for that. We could say dp of I and j equals, so we consider 2 movements. One is the down, so we could say dp of I plus 1, same column, plus dp of same row, 1 column forward. Okay. Now let's test this formula for another cell. For example, this cell. So to the bottom, I have 1, so it's going to be 1 here. And to the right, I have 2. It's going to be 2 here. So there are 3 unique paths, and that is correct. If I go down, I have 1 possibility. If I go to right, I have 2 possibilities, and I can sum them. So I get 3. Okay, now we can use this formula to fill out the remaining cells. So we could say 3, 1, summation is 4, 4, 1, summation is 5, 5, 1, summation is 6, 6, 1, summation is 7, 1, 2, summation is 3, 3, 3, summation is 6, 6, 4, summation is 10, 10, 5, summation is 15, 15 plus 6, summation is 21, and last cell, 21 plus 7 is 28. And 28 is the last calculation that we return as our output. Okay, let's start writing the code. Okay, we are going to have a function called unique pass. The inputs are m and n, and let me initialize our dp. We could say dp equals 1 for I in range of number of columns, and then this array for j in range of number of rows. So now we have a grid called dp that all of the elements are 1. So as we saw in our solution, the last row and the last column, we want the values be 1. Okay, so we are initializing dp 1 for all of the cells. Now we are going to just use our formula and say for I in range of m minus 2, because we are already filled out the last row, minus 1 in a reverse direction, and for j in range of n minus 2, minus 1 minus 1, dpi j equals dp of I plus 1 j for the cell underneath of that, plus dp I j plus 1. Okay, and at the end we just need to return dp 0 0. Okay, let's run it, and we get the answer 28 as we expected. Okay, now let's talk about time and space complexities. For the time complexity, we have a big O of n, where n is the number of cells in our grid, and our space complexity is also order of n because we created this dp here, that the size of that is as same as the size of the given grid to us, which is n by n. So as a result, our space complexity is also order of n. Okay, this is the solution of the problem 62 unique pass, and thank you so much again for watching this video.